3a. This is a question to ask us to find the value of the power. So the approach in Emaths is always the same. We compare the powers. So right now, what is the base that we should use? Yeah, we should use base 2. So let us convert everything to base 2. You're asking for 3a, right?
3AI or 3B?
Oh, there are two questions 3.
Yeah, boy.
So which one are you asking for? This one? Are you asking for this?
You're asking for both, right? You're all wrong, right?
Shh. Okay.
The fraction, right, is
This one you need clarification or not? Yes or no?
what is it?
In front, first way.
Yeah, you want to go through also can.
Do you need me to go through?
He wrong. He did it right.
Okay. Simplify the first one. 16 over x power 4 power negative 3 over 2. Let's convert the negative power to a positive power. What do we need to do with the fraction inside? We flip it over. So it becomes x power 4 over 16 power 3 over 2. So you notice that we do not have our negative power anymore. Okay, so now I can expand this. It becomes x power 4 to the power of 3 over 2. And at the bottom I also have 16 to the power of 3 over 2. And we expand it out. So we get x to the power of 4 times 3 over 2. We get x power 6 over 16 to the power of 3 over 2 is 64, yes. You can either use your calculator or your working will be as such. 16 power 3 over 2 is equals to square root of 16, then power 3. Okay, so it's 4 to the power 3. So this is how we get x power 6 over 64 for part 1. And in part 2, we have x divided by 5x power negative 5. So again, if I want to change my negative power to positive, I need to flip the fraction, right?
What's the answer? X over 6 over 64. Either you can find x, or x is 2. And simplify further.
You're talking about which one? Part 1? How do you want to simplify part 1?
It's 2 to the power of 6 on the way.
This one, is it?
Yeah, x is 2.
X is 2? Why do you say x is 2?
No x.
Oh, wait,
X is not... Yeah, x is a variable.
You never say it's equals to 1.
Exactly. Okay, so now over here, x power negative 5. If I change it to positive power, how do we do it? 1 over? 1 over 5?
5x
Wrong lah.
to the power of 5.
This is x divided by 5, 1 over x power 5, right? You know or not? X power negative 5 is 1 over x to the power of 5. Then we can combine. This becomes x divided by 5 over x power 5. Yeah, change the divide to a multiply. We get x multiplied by x power 5 divided by 5.
X over 6. X to the power of 6.
Any step you need me to go through, Yuling?
Hey, I never copied.
Now for question 3a, 2 power 30 divided by 60 equals to 1 over 2 power k. So just now we already said that the base should have been 2. Now in part A, let us change everything to base 2. 2 to the power 30 divided by 16. Okay, divided by 2 to the power 4 equals to?
Plus 1 over 2k.
Can I change it to base 2? 1 over 2 power k is equals to 2 to the power of? Yeah, 2 to the power of negative k. Now, 2 power 30 divided by 2 power 4, we get 2 power 26. Do you know why? Yes, equals to 2 power negative k. So k must be equals to negative 26. Do you need me to go through part B?
Use calculator.
Okay, shh. Okay, enough. Question 11. 11C. When I expand this out, I will get negative 10x squared plus 62x minus 50. So what were some of your suggestions of our alternative answers? Brenda, what did you have? Okay, 2 bracket, negative 5x squared plus 31x minus 25, is it? Any others? Okay, this is called factorizing. Yeah, it's not called simplifying. So we don't need to leave our answer like that. Sorry? You see, specifically the question asks you to expand. Expand and simplify. But after you expand and simplify, then you went to factorize again. So it doesn't really answer the question. Can? So you must know the difference between factorize and simplify. When we ask you to simplify, you will end up with individual terms without the brackets. Okay, then the next question was 16. Because nobody else had any questions in between. That includes you. Find the time taken for the water to reach a depth of 20. So, this one. Okay, so the depth over here, 20. The time taken. So, we need to compare two shapes. What are the two shapes that we are comparing? The first is the little pyramid at the bottom of a depth of 20. What is the other shape we should compare it with? First one will be this one in red. And the other shape that we should compare with will be, let me highlight it, this one, the entire thing. Okay, we need to compare these two. Now, are these two shapes similar? No, are they similar figures? Yes or no? Why do you think they are similar?
Because it's part of the same thing, right?
Then it's wrong. They are not similar. The red one and the big green one.
There's no red one and it's black.
Okay, the little black one at the bottom and the green one. Are they similar shapes?
Similar.
So what are similar figures? The ratio of their corresponding sides? The same, right? But what about the ratio of this one? Yeah. The width. Let's say the width over here is x. Then what is the width for this big triangle? It is still x. Okay, you see that the ratio is 1:1 for the small to the big one. Then now you consider the ratio of the small height to the big height is 1:2, right? Then what about the ratio of this length to this length? It is still 1:2. Because the only similar shape that we have will be this triangle and this bigger triangle. The whole 3D object itself, they are not similar figures. Understand?
This is the time we do in the
Yeah, we did it before.
You need to cancel the x one.
Yes. Yes, we've done this before. So, any questions? Anybody still has doubts whether these two objects are similar or not? Okay, make it very clear. Only the cross-sectional areas, the triangles, the 2D triangles, they are similar shapes. The entire object, they are not similar figures because the ratio of the length of the width, it is still 1:1. Okay, so how to do the working? We need to make use of the relationship of these two areas, these areas of these two triangles, the small triangle and the big triangle. What is the time taken for the entire container to be filled up? 12 minutes for the entire container. Then, what about for this little triangle at the bottom? Although the height is half, but is the volume half? So now we need to determine the ratio of the volume for the smaller portion as compared to the larger one, right? Okay. So let's compare the volume of the small, let me just call this shape C, okay? This smaller one. Volume of C to volume of B. This is what I need to find out.
Half times 20 times.
Okay, so volume of C will be equals to half times the base. How much is the base? How much is this? Come on, this is 20, this is 40. So since this is 60, this must be 30, yes. So over here I have 30. So half times 30
Times 20.
times 20 to get the area of this triangle. Then I times the width. Okay, Yipin wants it to be x, let's call this x. Times x. This is the volume of C
Over.
to the volume of B, which is half times 60 times 40 times x. Let us simplify. I can cancel away
Half.
the x, I can cancel away half, and I will be left with 600 2400. Okay, smaller to the bigger one. And we simplify it further, it becomes 1:4. Now what does this tell me? It tells me the volume of C is 1/4 of the volume of B. Can? Ryan, okay?
It's 12 divided by 20.
Then time taken
How many marks?
for 20 cm in container B is equals to 12 divided by 4, which is 3 minutes.
So this question how many marks?
I do not know.
Based on the experience.
I do not know, and I don't care.
3 marks. 2 marks. If it's 1 mark, I rather just don't do so much reading.
Okay, nobody asked about question 19, but I want to go through part C,
What's question?
the vector question.
Oh.
Then do you even try it?
No, I didn't have time. I got that busy studying my exam. Came back yesterday night. I went to Saturday.
Two facts about O, B, and P. So O, B, P will be somewhere further. So if you had drawn it out, okay, this one actually stretches all the way. It will look like O, B, and P, they are collinear. And that is what we will be trying to prove. Okay, we cannot conclude that they are collinear yet. But how do we prove that 3 points are collinear, meaning they lie on the same line? Sekian, what do you think? Magnitude. Huh? To prove that 3 points are collinear, it means that we want to prove that they lie on the same line. Okay, they must have a common point first, okay? Yes, they've said it already. So O, B, and P. We are trying to prove that either OB is parallel to BP, because if they are parallel and they have a common point B, then they will lie on one straight line. Or I can prove that OB is parallel to OP and they have a common point O. Then it will also prove that they are collinear. There is one more way to prove that they are collinear, but it may not always be useful. No, not gradient. Gradient is got to do with whether they are parallel or not. Another way is to compare the line segments, the distance, the length of the line segments. Okay, let me show you.
So what does length of line segments stand for?
No, it's just the length of OB
Or just for length?
and the length of OP. BP. If OB, if the magnitude of OB plus the magnitude of BP is equals to the magnitude of OP, then they are collinear, right? Because if they do not add up to be OP, then I am sure the line will look something like that. O, B, and P, such that OB magnitude plus BP doesn't equal to OP. As long as it is a coincidence, right, it means they are on a straight line already. Because there is no other way it can happen. But this is quite rarely used so far. But you should still know it lah. In this case, we cannot because I am unable to find out the magnitude of OB, BP, and OP.
So you set one question there.
If I find one, I'll let you know. Okay, so now to determine that O, B, and P are collinear, I will need to express OB in terms of BP or any other way. OB is already given to be 6B. And OP, did we have that earlier on? Yup, in part B, OP is equals to 12B. So now, can I say that these two vectors are parallel? Have I shown that they are parallel? Have I shown that they are parallel, Jingwei? Not yet, right? I'm missing one step. So to show that they are parallel, I need to write one in terms of the other. In this case, this will be equals to 2 times of 6B. Yep, which is 2 times of OB. Now with this, OP is equals to 2 times of OB. This tells me that OP parallel to OB. But this doesn't mean they are collinear yet. Since O is a common point, then O, B, P are collinear. Okay, so there are 2 steps, 2 things we need. First is parallel. Second is common point in order to prove collinear. Next is for question 27D. Okay, for this one, you need some background knowledge. Can you tell me what is the relationship between sine theta and sine 180 degrees minus theta? Are they equal? Okay. What about cosine theta and cosine 180 degrees minus theta? Are they equal? Can I make them equal? How? Negative sign over here. Okay. Is there something similar for tangent? Answer is yes. Tangent theta, tangent 180 degrees minus theta. Are they equal? So, how do we determine whether they are equal or not? Right now, can you use your calculator, choose any value of theta, find out what's the value of tangent theta, compare that to tangent 180 minus theta. Then you tell me whether they are equal or not. Try any number, any value of theta. Are they equal, Jingwei?
No, they are negative.
Okay, you say no, then you say yes. Are they equal? So are they equal? No, they are not equal. You realize that? Actually, there is the similar relationship, right? Between cosine and tangent. Okay, so this is the third one that I think wasn't introduced to you in your notes. Based on this, can we solve for part D? Tangent BCA over here. I can call this theta. Tangent BCA is actually equal to tangent 180 minus theta, right?
Negative one.
Wait. BCA is over here. This value is equals to 180 degrees minus theta, right? Follow me, Ipin? And tangent 180 minus theta is equals to, because I'm trying to form a right angle here. This is the same concept we use for cosine also and sine. This is equals to tangent, negative tangent of theta. And then, what is tangent of theta? Opposite, 1, 2, 3, 4, 5, 6, over adjacent, 1, 2, 3, 4, 5. Answer negative 6 over 5. Okay? Yes, you have a question, Ibin? Jolene, okay? Have you all memorized these two already? You all memorized these two? Because you need to either memorize it or understand it. That means you want to try and error lah. That means you agak know it looks something like that, and then you try and error to see whether it's correct. Then you better hope that the answers the numbers you press in right, and it's not a coincidence lah. It could be. If you want to know how we derive all these three, you can look for me. It's in your Sec 3 textbook. Yes. Okay, last one. 33B. One note. Okay, let's look at this one. Part 2. Y equals to 2 over x squared. This is of the form y equals to a x power negative 2. And we know that it looks like this. Okay, it goes closer and closer to the x and y axis, but it does not touch. So in this case, they specifically put in one point over here, 1, 1, to see whether you know whether the graph cuts through it, stays above it, goes below it, so on and so forth. So we need to consider when x is equals to 1, y is equals to 2 over 1 squared, which is equals to 2. So I know that when x is equals to 1, it should actually pass through this point. Passing through this point and yet having this shape, if my axes, they are very long, then it will look like this. And the other side also the same. And symmetrical as well. But because my graph is not, my axes, they are not so long, then you will end up looking at this. Now do you know why it looks weird, Ipin? So you say it looks weird, right? Why is it so fat, right? Yeah, no, this is the reason lah. Because the axes are not long enough. Otherwise, if you extend, it will look more familiar to you. Okay, any more questions you all have for this paper? No questions? Consultation will be going through the topical papers. Yeah, it looks like it. I thought I recorded it. Yeah, but either the computer is really lagging or it didn't record. Ah, okay. It recorded, I think.